Hey everyone, welcome back to our channel. Today we're going to tackle a question that has puzzled many of us in the machine learning community. Why does cv.calcHist return different results compared to np.histogram? If you've ever worked with OpenCV or NumPy for image processing and histogram calculations, you might have stumbled upon this issue. Don't worry. By the end of this video, we'll break down the reasons behind these differences and provide clarity on how to use these functions effectively. In this video, we'll delve into the world of histograms, exploring what they represent and why they're crucial in image processing. We'll compare and contrast the cv.calcHist function from OpenCV with the np.histogram function from NumPy, explaining the underlying mechanics that lead to their differing outputs. By understanding these concepts, you'll be better equipped to handle histogram-related tasks in your machine learning project. To grasp why cv.calcHist and np.histogram yield different results, let's first understand what histograms are. A histogram is a graphical representation of the distribution of numerical data. In image processing, it shows the distribution of pixel values across an image. This distribution can be crucial for understanding the contrast, brightness, and overall characteristics of an image. cv.calcHist from OpenCV is specifically designed to calculate the histogram of images or arrays. It's optimized for working with large datasets like images and provides parameters that allow you to specify ranges and bins for your histogram calculation. When calculating histograms for images, cv.calcHist considers the pixel values within a specified range and distributes them into bins according to the specified parameters. On the other hand, np.histogram from NumPy is a more versatile function designed to calculate the histogram of any array-like data structure. It's not specifically optimized for image processing, but can be used for it nonetheless. The key difference here lies in how these functions treat their inputs and outputs. np.histogram returns the bin edges along with the values, whereas cv.calcHist returns only the calculated histogram. Another crucial aspect to consider is the normalization process. When you calculate histograms using cv.calcHist, especially for images, you often want to normalize the histogram so that the total sum of all bins equals a certain value, like 1 or 100%. This step makes it easier to compare different images based on their histogram property. Now, let's address why these differences matter in your project. If you're comparing histograms across different images or data sets, consistency is key. Understanding how cv.calcHist and np.histogram operate will allow you to make informed decisions about which function to use and how to normalize the results for meaningful comparisons. Before we conclude, let's summarize the main points discussed. Histograms are graphical representations of numerical data distribution. cv.calcHist from OpenCV is optimized for image histogram calculations and offers parameters for customizing bin ranges and count. np.histogram from NumPy is more versatile, but needs to be understood in its own context, particularly regarding normalization and output interpretation. The choice between these functions depends on your specific use case, especially whether you're working with images or other types of data. And that's a wrap. And by now, you should have a clear understanding of why cv.calcHist and np.histogram give different results. Remember, the key to mastering histogram calculations in image processing is understanding how these functions operate and making informed decisions based on your specific needs. If you found this explanation helpful or have questions about anything we've covered, please drop them in the comments section below. Don't forget to like this video if it helped clarify things for you, and consider subscribing for more content related to machine learning, image processing, and programming insight. Until next time, keep exploring and stay curious.